Well, good afternoon, Ask. I wanted to talk to you today. We're looking at the project that we've started, and that is moving me. So I'm going to give some of those details of what you're actually asked to do as required. So on graph paper that we have here, I wanted to depict some of those techniques of being able to do some engineering graphics or engineering design concepts in this particular project. There's going to be three things we're going to ask you to do. I need you to be able to graph. Show the graph of the piecewise function. I want you to write functions of all pieces. With domain. And I want you to write an English piece that communicates each piece and the story of moving me. So those are the three pieces. Now with this, again, it shows on the rubric the three facets that I'm requiring you to do in that English communication. But I wanted to communicate to you again how to do some of this specific pieces of graphing and functions, and then show again what we did for that algebra. So for the next 10 minutes or so, this is your axis. We're going to use this as the distance. Part of the vertical axis, that's in feet. And then this is going to be in time. And the unit of measure for the time is going to be seconds. Design. This is a design product, so use design concepts in how you write and the facets that we've done. So really in that table that we had, if I had a table of information that we collected today on moving me, time and distance, and I'm just going to make up again some of my made up numbers of me moving. We started out with 0, 0, and in 15 seconds, let's say I moved 67 feet. And then I stood still for 45 seconds, so I was still at 67. And then another 15 minutes I moved, and let's say that I moved to 40. And so in 90 seconds I would still be at that, I would move again, or 40 seconds I would still be at that 40. So I'm going to plot some of this. You guys have more data than that. But the first thing you do is plot those points, 0, 0. And now you need to make sure the piece of material that you have in your window of graph gives you enough space and room to be able to get all the information, all the data that you've collected for your movement and for your moving me. And so I've got 0, 0. I want 15, 67. That's as high as I'm going to get with my data. So that's why I'm going to make sure I get this here on my graph. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 12 would be 60. So I'm going to go by 5s. So each one of these tick marks that I have on my graph paper, I'm going to have 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. And then 67 would be right in there. So I'm going to go 15. I'm also going to go making these tick marks worth a value of 5. So 5, 10, 15. And then I'm going to come up to 67. And I'm just plotting dots. That's the particular point. 15, 67. So that's the first dot, 15, 67. Well, 45, I'm at the same place. So 15, 20, 25, 30, 35, 40, 45. I label on my axis, and then I come up, I'm at the same 67th height, so I make that scatter of that plot. 60, then I move down to 40, so 45, 50, 55, 60. Label that, and then I'm down to 40, 5, 10, 15, 20, 25, 30, 35, 40. Is modeling that moving me, and then I just connect the dots. And so again, it's design technique, so use your straight edges incredibly well, connecting those dots with precision. So the design concepts and what you're communicating and modeling mathematically, you're moving me. We're modeling it with mathematics of a graph. Scatter plot of dots. This is called a piecewise function. title you could offer, communicating what we're doing. 3 pieces, 1, 2, 3. You guys have more than 3 pieces that you're going to be doing these things to. So I need to communicate. So that's how to graph. We're looking for those aspects: labels, axis, graphs, design, technique. Each of these pieces now, I'm going to write the function that models it. So again, off to the side of my scratch paper, I'm saying, well, let's call this D functions, because we're modeling the distance that you moved as time changed. So we want these dt's. Well, I need m times d plus b, where we start, what the slope is, as the time starts to change. So I want to have that as a particular function that I'm going to be using for each of these pieces. So in this b in this one, I see that where it crosses where I start, it was at the starting line. It was at 0, 0. So the b for this function is going to be 0. The slope, I know it's a direct variation, it's going right through the origin. So whatever this coordinate is, I can just take the rise, 67, and divide that by the run, 15. So that's going to be 67 divided by 15. There's your slope. So that's the rise over run. So that particular thing, and that's giving me my function. That's actually what I have. Now I want to call that the D1. That's the first piece of the story of moving me and what we're graphing and depicting here. So that first function, D1, that's what I'm going to be calling. I need to label that D1 of T. That function is going to be 67/15 times time. That's the function that models it. I'm writing it right next to that piece. Underneath that, I want to write the domain. Well, the domain of time that I was moving is starting at 0. So time is bigger than 0, but I only move 15 seconds. So that's the domain, starting at 0 and going to 15. The speed is always the slope. So speed is always the slope of the line, because it's depicting me moving. So that speed, that slope, is 67/15. I can change that to a decimal to communicate, and I want you to write it right underneath this. The speed is, this works out to about 4.5 feet per second. That's the speed of that piece. So in this part of the story of me moving, this graph, mathematically, is communicating to me in math language. I'm moving for 15 seconds in this domain at this speed, 57.5, so the steepness of that slope of that line is approximately 4.5. Depicted in units of speed, feet per second. Feet per second. Rise, feet divided by run. Seconds, feet divided by seconds. This next piece, I'm going to do the same 3 things. I'm going to call that D2 as time changes. And I'm going to have to calculate the slope and the y-intercept. Again, it's flat. For this time in the moving me, what were you doing? You were standing still. So what was your speed? 0. So that speed is going to be 0 times t. Well, that's just going to disappear. But I need to find where it would cross the y-axis. If I bring this line over here, it's at 67. So that's telling me that I'm not moving at all. 0 times x. You don't write that. But it stayed at what distance was I the whole time I was standing? I was 67 feet away from the starting point, away from 0. I was always, what was the distance at any time in that piece? I was 67 feet from the starting place, from home, okay, from the start line. Well, I also want to communicate what domain was I, the story of me moving, standing still. Why was I being lazy? Why was I a couch potato eating the potato chips and using the remote control? I wasn't moving at all. Well, what window of time was that? That was from 15 seconds to 45 seconds was my domain. The domain of that function that I'm using for this piece, or this piecewise function. That's 2 pieces. What speed was I going at? The speed I was traveling was 0 feet per second for that piece. So I'm going to go one more time, one more example here. I'm going to write the function. This is the most difficult one. I'm going to, whoops, I'm not using that as F. Dang it. I would like to try to erase that if I could. I can't, so I'm just going to black it out. The distance, this is D3. This is the 3rd piece. So I take that distance and I'm going to find out the slope and the y-intercept. The slope is possible because I can take these coordinates of 45, 67 and this coordinate of 60, 40. And I'll show you again how this is Algebra 1 level to be able to find that slope. I can just subtract the x's, subtract the y's, and go rise divided by run, y's divided by x's, and be able to determine that slope. So 67 divided by 40 is 27. And 45 divided by 60, subtracting in the same direction, I get negative 15. Well, that gives me a negative slope. Should it be negative? Yeah, the slope of the line is coming down, right? Also, in this particular moving me, I moved back toward the home base. Here I was at 67, there I was 40. So now I'm closer to the starting line as time was going on. And so I did that. That's the slope of it. But now I need to find where the y-intercept is. So over here on the side, I'm going to show again in my scratch paper, I'm going to be working, finding that b. So I'm going to change that distance to y. I'm going to take it out of function notation just for a second to be able to calculate this b, or where this line would cross the y-axis, where we would start. If I extended this line on out, this piece on up, I'm estimating it's going to be crossing up there. Can you estimate where that might be? If this is 70 and we go up to there, guess where that would be. So again, what I would do is plug in, I have values for t and y. I need to be able to just plug in values for t and y, or t and d, if you want to call them that. And I have 2 points on that line. I can use either 2 points. I can use 60, 40 or 45, 67. So the distance is 40 when the time is 60. And so I can just plug those numbers in and then be able to find, solve for that b, which is representing the y-intercept, where this line would cross up here this vertical distance axis. So again, this is stuff we practiced back in Algebra 1. So I can multiply all these numbers, and if I remember what the calculator said, this was about 108. If I multiply and divide, 27 divided by 15 times 60 is about 108. If I move that over, I get positive 108, and that tells me that 148 is b, approximately where this line would cross. This being 70, is that another 70 to get 140? Okay, so that's what we're looking at. So it looks pretty reasonable. That's my b for my function. To find the domain, again, what is that domain? What part of the time was what interval of time did I, in this piece, did I move at this speed and have a starting place if that function designs or crosses the y-axis up there at the y-axis? It was in that window of time from 45 seconds to 60 seconds. What is my speed during that interval of time? The speed is the slope of the line. Slope of the line is negative 7. 27 divided by 15. That estimates to about negative 1 point, I think, if I remember the number. Double check me with your calculators. I may be wrong here. But I think it's around 1.8 feet per second. Is this piece, was I moving slower than here? Yeah. The steepness is not as great. But it's also in a negative direction, meaning I was moving back. Okay? So that's the distance, that's the function, that's the domain, and that's the speed of every piece. That's what I want to see on your graphs as you move through this other piece. As you go through here, you're going to have another flat piece because you were standing for another 30 seconds. Continue that process on your graph paper and get it into me by Monday. The other thing, the last thing that I want you to do is down at the bottom, maybe on another sheet of paper, you write down in English the speed, direction, and duration, telling the story. So this D piece, you need to tell me, I was moving at 4.5 feet per second for 15 seconds away from starting line. Starting point. So that's, I need you to do that for every piece. I think you have about 6 pieces that you did. finish that up. Bring as much as you can that you've worked on and completed in this project due to me Monday. We are the Yes Academy.